Right, we are looking at question 3, and this question 3 is part of what must be discussed, and it is extremely important for us to look at how we can prepare better for the exam. So this paper I've loaded, it's a full exam paper written by the students of the province of Gauteng, and I want us to discuss this and see how well we can do this. So we're considering the point A with coordinates -1, 4. We shall do a lot of the questions. The point B has the coordinates P and -2. And we have an extra point, C, and these are the vertices of triangle ABC. E is the y-intercept of AB. Here is the point E. It is the y-intercept of the line AB. Here is the point E there. F is the midpoint of BC. F is here, the midpoint of BC. The angles of inclination of AB. AB has the angle of inclination 135 degrees. And alpha, respectively. Obviously, so this alpha is an angle of inclination of AC, and the angle of inclination of AB is 135 degrees. What is the question? Calculate the gradient of AB. So they wanted the students to be able to calculate the gradient of the line AB. And how does one do that? And the marks were only 2. So it's straightforward. This is the point A there, and this is the point B. So how do we therefore find the gradient of the line AB? So in other words, here we start as follows and say the gradient. Right, so the gradient of the line AB, because we have been given the angle of inclination, it actually therefore is the tangent of 135 degrees, and we use our calculator to do this. And the tangent of 135 degrees is -1, and therefore the gradient of the line AB is -1. So we have solved this question from the trial paper. I'm going to give you a lot of the questions from each province. I have got all the trials of 2023 from all provinces. I'm going to send to you to practice so that we can discuss together, and they will serve as your homework in the other provinces. Right, let's look at the next question. Now they're saying show that P equals 5. Show that P equals 5. Where is P? Right, P is here, and they're saying show that P equals 5. So obviously that one is very straightforward to show that P equals 5. So to show that P equals 5, there are a couple of things you need to consider. So that is actually question 3.2. And now we consider the fact that P is here and need to show that it is equal to 5. But we know the gradient of AB is actually the same as -1. But also we know that the gradient of AB is x1, y1, and this one is x2, y2. In which case, therefore, this is y2 minus y1 divided by x2 minus x1. What is the gradient of AB? It is -1, and y2 is -2 minus y1 is 4 divided by x2. It is p minus x1 is -1. So this one becomes p plus 1. You cross multiply. It's minus p minus 1 equals -6. So what is p? So p is -5. If you move the 1 to the other side and you divide, it becomes exactly the number 5. So in other words, p equals 5 there. So they asked us to show that the value of p is 5 for 2 marks in 3.2, and we showed clearly that p equals 5 here. Okay, we showed that p equals 5 there. Next question. Now they then said calculate the coordinates of the point C. Here is the point C, and we need to calculate the coordinates of the point C. But obviously you already know that p equals 5. So this is 5. How do we find the coordinates of the point C? So this one is very obvious. At the point C, you can see therefore that the point C has the coordinates xc, but also it has the other coordinate yc like that. Right, so this one is the midpoint. So we're going to use the midpoint formula. So using the midpoint formula says we take the x value here, and then we take the x value at c, we divide by 2, and the result is the x value at the midpoint, which is 0. And also, we take the y values. So we take the y value -2, we add the x value there, which is the y value rather, we add yc, we divide by 2, it must give us the y value of the midpoint, which is -4. Right, we cross multiply 2 by 0, and 2 by 0 is 0, and we transpose the 5 to the other side, it makes it negative. But also we cross multiply here, 2 by -4 is -8, so that yc is the same as what? Right, so it is exactly -6, okay? 2 by -4 is -8, and then you add 2 to -8, it becomes -8 plus 2. -8 plus 2 is -6, and that gives us the coordinates of the point C. So in other words, the conclusion therefore is the coordinates of the point C will therefore become -5 for x, and the y is actually -6, okay? So we have that, and that is very clear. Now in 3.4, they're saying determine the equation of AC in the form y equals mx plus c. Right, the equation of the line AC. Right, so that is very, very obvious, because we already know the coordinates of the point C, and these ones are -5 together with -6 as coordinates, and therefore we are looking at the next thing to actually show that or determine the equation of AC. Right, here is A and here is C, and we want to find the equation of AC. How do you find the equation of AC? Right, so that one is very obvious, and we proceed to do it here. Right, first things first, we realize that the point, the line segment AC will actually be from here to there. And you have the A with the coordinates -1 and +4. And you have the C, whose coordinates we just found are here, -5 and -6. Okay, we have those coordinates there like this. We want to find the equation of AC, but to first find the equation of AC, we need to find the gradient of AC. So now we're gonna say the gradient of the line AC is what? Right, so it is x1, y1, and this one is x2, and this is y2. So, okay, at this point, then what is actually y2? You start with y2, then you subtract y1, you divide by x2, which is -5, minus x1, which is minus this. And what is this if you simplify everything here? Right, if you simplify everything here, it becomes 10 out of -4, which is 5 out of 2. Right, we're good. And then what is the equation? To get the equation, we're going to use the most famous formula, which says y minus y1 is equal to m into x minus x1, like this. Right, so what is this? Right, it's y minus, but obviously we're speaking of the equation of AC. So it's y minus, what is this one here? It's x1, y1. What is y1? It's -6. The gradient is 5 out of 2 into x minus. What is x1? It is -5. So you simplify everything here, right? If you simplify everything, you divide here a bit to separate the top from the bottom. So now, yes, please. Okay, we continue. So if you simplify everything here, this will be 5 over 2x. And obviously you multiply these as well. and this is plus 6, you move it across. 5 over 2 times x becomes 5 over 2x. When you add here, subtract. So what is then the result here? Because we want to find the equation of AC in that required form. So 5 by 5 is actually 25 out of 2, and then you subtract 6. So it means, therefore, you subtract 12 out of 2, which is 13 out of 2, which is the same as 13 out of 2. And so that is the equation of AC in the required form. Next question. Next question, they're saying calculate the size of the angle CAB. Yeah, is that a question? No question, right? Does anyone have a question? No. Yes. I don't know if anyone has a question. Okay. So we're looking at the angle CAB. We're looking at the angle CAB. Okay, where's angle CAB? CAB. So we're looking at this angle. We're asking the question, what is the size of this angle here? We're asking the question, can that angle be found? So if this angle can be found, then we're so good. And then we can be in a position to deal with it. And so we're asking the question, what is the size of that angle then? There are many ways to do this, and we proceed to use any of them. Right, and the easiest way is to first realize that this one is a triangle here. And if you have that this one here is a triangle, like this, and this one is also a triangle. From grade 10, we learned that if you have a triangle like this, then the exterior angle is equal to the sum of this one with that one. So obviously, we just need to get alpha, then this 135 is alpha plus this, and then we can just get the question mark there, which is what the examiner actually is asking us to find in this question. And therefore, we get started with the mission. But first, we must just find alpha, but do we know the gradient of the line AC? Yes, we know the gradient of the line AC because we have already found it. So, and this is going to help us to find alpha. So the gradient of the line segment AC. So now we continue with that one. So we find the gradient of the line segment AC, which must be the tangent of the angle of inclination. And this is a 5 out of 2. This is good news. Right, what is alpha? Right, from this we're able to see that alpha is actually arctangent of 5 out of 2. Arctangent of 5 out of 2. Right, so we continue now. We continue right now. Okay, right. Hello, someone's father. Fine, thanks, and you, someone's father, and good morning to you. Yes, please. Yes, he's writing MAT 2613 tomorrow. And yeah, yeah, definitely, I agree. And so in particular, we discussed that we shall have our discussion today at 4 p.m. And yeah, we can do extra. We can do extra. Possibly, I was just planning that we can discuss, when we meet at 4 p.m. Yeah, we can extend. We can have the normal 2 hour because we're gonna have a 2 hour discussion, and then we shall take a break, and then you can always get back again. For example, we can do from 4 to 6. That's the period, the standard 2 hour discussion or lesson time. And then we can take a break for 30 minutes and return afterwards. We shall discuss the length of the break we shall take and return again for the next the 2 hours. I'm sure that that allow us to have a discussion of about 4 hours. We must actually be in a position to exhaust much of any queries or outstanding content. Okay. Yeah, that's fine. Yeah, yeah. 4 o'clock sharp. 4 o'clock sharp. Okay. Yeah. Okay. Yeah. Thanks a lot. Thanks a lot for helping Saman. Saman's father. It's appreciated. Okay. Okay. Thanks, then. Goodbye. Mhm. Okay, we continue. I was looking at these now. Then we get the answer to this. What is the answer to this? Right. So we're gonna uh, get started with this, and we're gonna enjoy ourselves, and we're gonna solve lots of the problems. Let me just get a calculator here so that we can also enjoy using our calculator. There's a calculator on the screen, this one here. Right, so let's use this calculator to do the calculation we need to do. Right, so what do we have? For example, we have 5 out of 2 are 10. Right, so if we say 5, we divide by 2, what result do we get? Okay, we get 2.5, and then now we are looking for the arctangent. So we analyze the arctangent is up there. So we can do shift 10 of the answer, and the result is there. So what is the result? So the result is actually 68. Right, we saw that the result is actually 68.199. So it is actually 68.199, something that way. Degrees, okay, that is the angle alpha. So if this one is the angle alpha, then we are in a position to get exactly what is wanted. And so what is actually wanted here? What is wanted is the size of CAB. The size of CAB. So then from this we're able to see that the size of CAB, so angle CAB, is actually, from the triangle we have this kind of a situation. Right, so we have this kind of a situation, and then we have 135 degrees. Right, so we have 135 degrees here. And then we have this one is actually the alpha. And then we need to find this angle there. How do we go about this one? So we know therefore that 135 degrees is actually equal to that. Okay, so we can just continue to do that over here. So what then do we achieve? Okay, right. So we are able to achieve the fact that from this point here, we have the 135 degrees. 135 degrees is actually equal to alpha plus the CAB, because we have therefore that at this point here, this one is C, this one is A, and this one is B. Right, so the 135 degrees is alpha plus CAB. So we have this. What is alpha? We know already that this is 135 degrees, which equals alpha. What is alpha? Alpha is actually 68.199 degrees plus CAB, like this. Right, so we do the calculation here and the subtraction. And what do we do as the subtraction? So it means, therefore, that is CAB is equal to 135 minus 68. So now this is the result. So this is about 66.8 degrees approximately. So that is the angle they wanted. So what do we need? Therefore, we have this result, which is actually exactly this one here. Okay, 68.8 degrees. Okay, right. Next, we want to find the area of the triangle BF. The area of BF. So what do we do right now to get the area of triangle BEF? Right, so now the area of triangle BEF. Right, so to find the area of triangle BF in 3.6, we can realize that if you look at the diagram, here is the diagram. And you want to find the area of B E F. Okay, there is a triangle there. So there are a couple of ways to consider this. What are the coordinates of any of the points here? Okay, the coordinates of F are these. What are the coordinates of the point E? Do we know the equation of the line segment AB in any of the questions? The gradient of AB is known. CAB is there. Right, so we can be in a position to calculate the coordinates of this. Okay, because if we can be able to find the coordinates of the point E, then we'd have made significant progress. What are the coordinates of the point E here? Okay, right, so we don't know the equation of the line AB yet. We found that of AC, so how do we calculate now the equation there? Right, we need the equation of AB, Mr. Examiner. Okay, so now we are interested in finding the equation of AB. Right, so to find the equation of AB, we have this one here. We have this one here, which is A, with the coordinates -1, 4. And then this one has the coordinates B, 5, -2. Okay, we have this. How do you find the equation of these? So the equation is actually the gradient first. Find the gradient. What is we know the gradient is -1, so yeah, there's no need. Right, because we already know the gradient, the fact that the gradient itself is -1. So there's actually no need to do that. Right. So what do we then do here? So we just are able to exactly get what is required here. So I can just remove this. Okay, I can just remove this. So now we can find clearly the required gradient here. Okay, right. So how do we find the required gradient or the required equation of the line? Y minus y1 equals m, the gradient, into x minus x1. So it's y minus, okay, we choose any point on AB. So we can take the point, choose B. Choose B. So this B will have x1, y1. So you have y1 is -2. The gradient is -1 into x -5, like this. Okay, we just simplify everything. So this is -x plus 5, which is 5 minus 2, which is -x plus 3. -x plus 3. All right. That's what we have. So this is the equation. So it means we can find the point E lies somewhere here on the diagram. So if x is 0, y will be 3. 0, 3. So this one would have x is 0 on the y-axis and y is 3. So with this said, now we're in a position to get the answer. What is the answer? The answer then is that we can find the area with ease of this question. What is the area of the triangle BEF? BEF, what is the area? Right, so we can do half base times the height, right, or the perpendicular height. Right, so now that is what you're gonna do. The area is half base by height. So we're gonna do it here and say the area of triangle BEF is half the base, which is EF, multiplied by the perpendicular height, so which is half the EF. What is EF? Okay, because it's just the y-axis and y is -4. So from the origin, you go down -4, but from the origin, you go up 3 units. 3 plus 4 is what? It's 7. 3 plus 4 is 7. So which means that this here is actually 7. So which is the base multiplied by the perpendicular height. What is the perpendicular height? So from here to there, the perpendicular height is the y is actually the x value because we are progressing horizontally. And so we can see therefore that the perpendicular height can be measured from here to there. And it is exactly the x value, and x is 5 units there. Okay, so because p is 5, so we have therefore that x is 5 units. But the perpendicular height is actually 5 units. Right, so as a consequence, we have this result here. So what is the answer here? So the answer here, if you multiply 7 by 5, is 35 divided by 2, which is actually 17.5 square units. Square units, which is the area. Square units. So this one is the required result. So we actually obviously are solving a couple more things at this point. We are getting the result that is wanted, so we good enough. We good enough. So the next thing. Okay, and the next one is just 3.7. And question 3.7 says another point K with the coordinates T and T, where T is negative, is plotted such that AK is 5 the square root of 5. Calculate, write the coordinates of K. Calculate the coordinates of K. Right, so this one is very, very straightforward as well. How do we find the coordinates of K? Right, because we have been given that AK is this. Right, so you have A with the coordinates -1, 4. And we have A is this one. We have K. What is K? K has the coordinates T and T. K has the coordinates T and T, but T is what? Is negative. So, but we know the distance between A and K is 5 to the square root of 5 units. So this is 5 to the square root of 5 units. That is the distance between A and K. Right, with that said, we are in a position to just solve this question. So it means the distance. AK is 5. The square root of 5. This means AK now is going to be actually the square root of t plus 1. Right, so if you have the square root of t plus 1, right, the square root of t plus 1. Okay, so you continue. What is the square root of t plus 1? Right, so we continue to find that one. Right, so we have the square root here of t plus 1. You square this one. So we're dealing with this one minus this one. Next, t minus 4. You have a t minus 4. You square everything here like this. After squaring things that way, we are in a position to continue. So you close this one. This is 5 to the square root of 5. So we have this one squared. So if you square this one, does it become? So this means, right, so you can square both sides of the equation, which means you have the square root of t plus 1, which you square. You also have a t minus 4, which you square, which equals 5 into the square root of 5, and then you square. So we have this. So now we square like this. Okay. After squaring both sides, you have t plus 1. But t plus 1 is the same as t squared, twice t plus 1. This one is t squared minus 8t plus 16. And this is the same as, right, it is the same as 125. So this is 2t squared minus 6t. This one plus 16 is 17. You subtract 125 is minus 54. Okay, I had lost him, Paul. Okay, I'm sorry. If I lose you, you're not gonna lose anything because this is being recorded. Sometimes I lose you because of the network. It's something that cannot just be justified. So if you divide here through by the 2, what do you get here? So you get exactly t squared minus 3t. Okay, right. So we have that. So you have t squared here. Okay, and then you have what? Right, so you have here minus 3t. Right, so that's fine. So if you continue with these, you can divide through by 2 here, and that gives us t squared minus 3t minus, what is 54 divided by 2? It is actually
27.
27. Well done. It is 20. Okay, I made a slight error here. Thanks for obviously mentioning that. Need to make a small change here. But it would be 27. But right, 1 plus 16. It's 17. And then what is 125? 17 minus 125. Okay, so it is actually 108. Okay, so that would be 108. So note that here we shall have just 108. You divide 108 by 2, it becomes 54. Good. Right, so we're on track now. Okay, we're just looking at the trial paper of the Gauteng province and we're discussing it together. Right, so if you look at this, then you divide everything here. So we are going to have minus 9 into plus 6, t plus 6 equals 0. Right, and this is the same as t equals 9 or t equals minus 6. T equals 9 or t equals minus 6. From which we're able to observe, therefore, that the coordinates of k, because t is negative, so we're going to choose the negative value because this one is not applicable. So we're going to choose minus 6 minus 6. Minus 6 minus 6. All right. We continue. Right. Next question. Right. Next question, 2023 Gauteng is a circle like this. In the diagram below the circle centered at M with coordinates of minus 2 and 3, this circle passes through the point A with coordinates 1 and minus 1 and C. This circle passes through A, but also it passes through C there. Okay, so we're good. Let me just to remove this. And let me just to remove this as well. Right. So we have BA and BC are tangents to the circle at A and C respectively. So we have BA and BC, those are the tangents. Right, with BC parallel to the y-axis, here's BC is clearly parallel to the y-axis. Okay, we can see that. Next question. Determine the equation of the circle in the form this. Okay, so this one is very straightforward. What is the equation of the circle in that form? Right, so you can easily be in a position to compute that one. And so what is the equation of that circle? So to find the equation of the circle, there are a couple of things we need to consider. And what we need to consider is basically the radius of this circle. So in other words, the equation of the circle that the examiner wants would be given by here. Right, it should be clearly given by, because here's the point M. So it's going to be given x minus a. The formula is x minus a squared. Y minus b squared is r squared. AB. So you square this one. So you have this, which is the radius, the distance here. So now to find the distance, then we just need to find the radius. The radius is actually that distance, which is the same as also this distance here, the point C. So what is that distance? It's the radius. So what would the distance be here, for example? What would the distance be here, for example? Right, so this distance can be easily determined here. Right, and so to easily determine this distance here, what do we do? So this one is actually r squared, like this. Okay, so you learn the tricks of the examiners here. Let's go up. So this one is x plus 2 squared. Okay, and then the other one is also for the y. Then you have been given an extra point. So if you're given an extra point, learn the tricks of the examiners, because this one is going to be y minus 3, which is square. And this is the r squared. That is the equation of the circle. But this here is exactly what we desire. And so we have the answer. So we have these. So which means, therefore, there is another point A. This circle passes through A. So this circle passes through the point A. Okay, this is one trick that the examiners normally use in the exams. So you have the coordinates of the center given, but another point is given, and you're asked to find the equation of the circle. So if you're asked to find the equation of the circle, like in this case, you realize that the circle passes through the point A. Right, so the point A therefore will give us x and y. So we have x, which is 1 plus 2, you square this. The y is minus 1, so is minus 1 minus 3, and you square this, which is equals r squared, which means r squared is 9, because 1 plus 2 is 3, you square it's 9, and then this one here is minus 1 minus 3, which is minus 4, you square it is 16, and then from which we're able to get that r squared is 25. Okay, right, we are in business. So if it is 25, then it means that we have x plus 2, which you square, and then you have y minus 3, which you square, and therefore this equals 25, and that is the result. And that is the result. Okay, and that is actually the result over there. So therefore, this one is x plus 2, and this one is y minus 3. Okay, that is the equation that is wanted. But another way would be to find the distance between these, because that is the radius using the distance formula. And therefore now, if you find the distance between the center and a point on the boundary, on the circumference of the circle, that also is nothing other than the radius. So you can use the distance formula to find the radius, but you can also do it like this. So learn the tricks of the examiners. The method I use here is the most standard way and the most immediate one the examiners would use there. Okay, in the marking center. Right, so in the exam marking center, we obviously consider standard methods that can be used first to solve the problems. We need to find now the coordinates of C. Where is C? C is sitting here. What are the coordinates of C? Too obvious. Too obvious, right? So now, to find the coordinates of C, we're going to use symmetry. We're going to use symmetry. What are the coordinates of C? Right. The radius. What is the radius of the circle? If radius squared is 5, so this is 5 squared, it means the radius is 5 units. So it means that here we come here, the radius is 5 units. If the radius is 5 units, what is therefore the distance from here to there? Because that is what we want. So we're going to use symmetry to do this question. Right. So we realize a couple of things, that by symmetry, the distances are just the same across. The distance from here to there is the same distance from there to there. So we can use the notion of symmetry about the origin, about the center of the circle. Now, if this one is minus 2 for x, and then we progress along the x-axis 5 more units, where are we going to get to? What number are we going to reach? So in other words, we have the minus 2, but we progress a further 5 units. And then we have the y value is 3. Y value remains the same because we are moving horizontally. So like y here is 3, and it remains that. So which means C becomes minus 7 and what? And 3. So the coordinates of C are minus 7 and 3 by symmetry. By the fact that the same distance of the length, same length of the radius becomes the same for any other radius. So we say these are radii. These are radii. And then, right, I lost Paul. I'm sorry. Any question?
Yes. Can you hear me?
Yes, I can hear you loud and clear. Welcome. I'm speaking to Waruna.
Hello.
Is that correct? Yes. Is it Mpo or Waruna?
Okay. Yes,
Okay.
it's Waruna.
Whoa, thank you so much, Waruna. You have a question?
If C, yes, sir.
Okay, please ask the
If
question.
C was not in the same, if C was not in the same line as M, how would we have calculated Y?
Okay, you're breaking up. Please come again. I missed I missed the crux of your question.
Hello. Oh, must I type it? Let me type.
Okay, are you saying that because I'm so sorry the network is bad? Okay, if it breaks and you can't hear me well, you can watch the video because I know very well sometimes the network is bad and you cannot hear me very well. So you will have to watch the video. The video cannot break because it is recorded from my position. So the audio is 100%. Okay, right. Let me see the chat. Okay, good. Right. That is your question, Waruna. It says that if C was not on the same line as M, okay, so in other words, if C was not, right, if C was not on the same line as M, okay, yes, how would you have found Y? All right. Right. So that's a good question. How would we have found Y? Right. Maybe if C was a yes, that is the question. Correct. Yes. So yeah. Um Here the easiest part of the question is because it has just been put on a tangent. It has been put on a tangent, but this tangent that is such that it is most certainly parallel to the y-axis like that. Okay, so this is one thing you need to note here. If C was not on the same line like here, how would we get the coordinates of C, for example? Okay, so obviously there are too many things we could use. So we could use the distance formula. We could use the fact that the radius is known. If the radius is known, you could say, for example, you have the xc and yc. You do this, and therefore now, if this is the case, um, the examiner would have to give some extra condition because if the point C would be like in the diagram as I've drawn it, it would be such that um, um, it's not unique. So there are many points C like that. So you can have a point C that is here with the coordinates x, c, y, c. So as a consequence, in the end, the points C are many. And if you combine all the points C, they trace the circumference of the circle. So this is formed by too many points that are equidistant from the center of the circle. Okay, so yeah, the examiner would have to give you extra information in that case. They would have to give you extra information if it was not on the same line as M. But yeah, a good question there, Waruna. Thanks for raising that up. Okay, next question. Right, next question. Right, so now we want to find the equation of the tangent AB in the form that 5 marks. The equation of the tangent AB. Right, so we have A here and B. We want to find this equation. How do you find this equation? Okay, it's obvious. It's obvious. Right, to find the equation, first you realize that AB is here. It passes through the point A with coordinates 1 and -1. And but now you need to find the equation of a line. You need to find the gradient of AB, but B does not have coordinates that have been given, so you need to find and A. So this is what we have. A has the coordinates 1 minus 1. And you have this one here. Minus 2, 3, like this. Right, so with this said, now, what is this? Okay, this is a tangent, so it's just perpendicular. A tangent is perpendicular to the radius. So we want to find the equation. So first we must find the gradient of AM. So we start here by saying the gradient of AM. What is the gradient of AM? Is this one is x1, y1, this is x2, y2. What is y2? Is minus 1. Y1 is 3. Divided by x2 is 1. X1 is minus 2. So it is actually minus 4 over 3. So we have this minus y1 equals m into x minus x1. So it passes through the point A. So you have y minus y at the point A, because we're interested in finding the equation of the line AB. So to find the equation of the line AB, we realize that it passes through the point A. So you have y minus the y there, which is y minus y1 equals m into x minus x1, right? Which is y minus, what is the y value there? It is minus 1 equals the m, the gradient of the line AB. Right, okay. What is the gradient of the line AB? So the gradient of the line AB is equal to, because they are perpendicular to this, so the gradient is going to be, you multiply it by negative, or and then you reciprocate. So it becomes 3 out of 4, because this one is 4 out of 3. One is negative and the other one becomes positive because they're perpendicular. Okay, the reason for this is because the gradient of line 1, the gradient of line 1 times gradient 2 is minus 1. If you have line 1, line 2, wherever line 1 is perpendicular to line 2. So as a consequence, what we are then getting is that the gradient is actually 3 out of 4, which is x minus, what is x1? All right, so x1 at the point A is 1, like that. So we have this. Or if you simplify everything here, what do you get the equation to be of the line in 4.3? Right, so the equation is going to be 3/4 of x. Then now you have minus 7 into 4. Okay, so this is the answer to the question. So that is 4.4. Okay, next thing. That is 4.3, excuse. 4.3. Okay, right. It is 4.3 because now we're just finding the 4.3 because we're just finding the equation of the what? Of the tangent. So in the form y equals mx plus c. So we have found the equation of the tangent in the form y equals mx plus c, and that's the answer. We have this. Okay. Okay, we have this. So the next thing is that in 4.4, we therefore need to find the length of BC. What is the length of BC? Right, so the length of BC can be found. Right, so the length of BC can be found. Let's check. Okay, we're interested in the length of BC, so from B to C. What is the length from B to C? Right. So we know what this is. Right. We know what this is. I'm giving you 2 minutes. 2 minutes to find the length of BC from B to C. 2 minutes. And then you let me know when you're done. You let me know when you're done. Two minutes only of practice.
Sir, please go down so I can see the
Question?
coordinates of B.
Okay.
Thank you.
All right, fine. Right, we're interested in the length of BC. That is what is wanted. The coordinates that determine the length of BC. Okay. You can see that you have seen the coordinates of B, but obviously I must show you the diagram as well, so that you can deal with, because you just need to find the, the length of BC. That's what the examiner wants. You're saying determine the length of BC. BC, the length of BC. The length of BC. You let me know when you're done. Okay, doesn't matter. I've given you the time to try it. So let's just get cracking now. Right, to get cracking, let's do this. Let's do this. Right, so we need to remember that we just need to find the distance from here to there. Right, so because this one is parallel to the y-axis, parallel to the y-axis, because of this, it means that it starts the x-axis at the same value as the coordinates of C. So you have minus that. So it means that here this point is actually -7. The x value is -7. With that said, we continue to solve the problem. Okay. It means that the x value is the same on the line. And the equation of this line, if the examiner were to ask, would be -7. So the coordinates of the point B would therefore be x equals -7 for the x, and then we just need to get y. But you already know the equation of the line AB. What is the equation of the line AB? So this one has the equation y is equal to 3/4 of x minus 7/4. Okay. If you put minus x here, The -7, excuse me. So you have 3 out of 4 into -7 plus -7/4, and this is the same as, y equal to something. Y is going to be -7, exactly. So the coordinates of B will be -7, -7. So we just need to find now the length of CB. Okay, so it's obvious. How do you find the length of CB? So it means, therefore, that CB, the distance from C to B, from C to the x-axis, and then from the x-axis to here. What do you think? No. Okay, from here to there, it's going to be 3 units. Because y is 3. So y is always 0 on the x-axis, but you go up to C and then y is 3. Okay, and then you realize that from here to there, y is 0 here, but now y, this is x and that is y is -7. So it means that CB is 3 plus 7 units. 3 plus 7 units, which means CB is the same as 10 units. Is the same as 10 units. So CB is 10 units. Okay. CB is 10 units. Right. But you can use the distance formula to find it, but the distance formula is okay, but the x value, if the x values are the same, or if the y values are the same, you just, because here x is -7, x is -7. So to get the distance, it's only the y that changes. So it's the one that's going to give us the distance, which gives us 3 plus 7, which is 10 units. Right. So obviously the distance is never negative. So if y is -7 here, but you can't say the distance from there to from here, it's -7. So it must be exactly 7. Note the analysis of this question. Guys, I'm yet to discuss with you this coming week. We need to work day and night to do the trials of all the 9 provinces of South Africa. I have the trials with me of the Northern Cape, of the Western Cape, of the Eastern Cape, you name it, of Limpopo, all the 9 provinces. And I'm going to give to you. We're going to discuss together. Please, you guys need to make time. You need to make time in the evenings. If during the day you are busy, then let's discuss in the night, maybe from 8 until 10 or something. If in the night you need to sleep, then we discuss for 1 hour, 8 p.m. until 9, or 6 to 7 p.m. if 8 is late. But we need to make time because we don't have time. The exam is a few days away. So we need to practice all the 9 provinces. There, I have all the trial question papers. Yeah, I have them on my screen. So yeah, but I'm just doing the Gauteng now. Okay, right. So if you look at 4.5, they're saying determine the equation. Okay, I hope there's no question. 4.5, determine the equation of the circle centered at A that has both the x and y axes as tangents. The examiner is telling us in 4.5 that there is another circle. The circle is actually centered at A, but it has both the x and y axes as tangents. Centered at A. So let's look at the diagram. There's a circle that is centered at A, but it has both the x and y axes as what? As tangents. So if this is the center, then the circle is going to be like this. It's going to be like this. Such that it touches. To touch a line, it becomes a tangent. So if the circle touches the line, it becomes a tangent. This is it. This is it. So what is the examiner asking us? This small green circle here, and the examiner is saying, determine the equation of the circle centered at A that has both. How many marks? 2 marks. I'm giving you 2 minutes. I'm giving you 2 minutes. I'm giving you 2 minutes. Let me know when you're done. One day question of that green circle. It is centered at A. So A is the center of that circle. But it is having the X and Y axis as what? As tangents. Please deal with it. Anyone who is done? 2 minutes. Okay. Anyone who is done? Anyone? Anybody home? We need to train like the army. We need to train like the defense force. This coming week, we are declaring war this coming week, day and night. 6 to 7 p.m., 6 to 8 p.m. I like 2 hours because then we have enough time to practice. We can try more questions in 2 hours than 1 hour because time is a bit short. So yeah, you can let me know. So I'm just suggesting to you. I know that you have your own plans, but yeah, just think about it and you will let me know. Oh, righty. We continue. We continue. Okay, no one home yet. Never mind. What is the examiner interested in? The equation of the circle, open 5. The examiner is saying determine the equation of the circle centered at A that has both x and y axes as tangents. So you have x minus A. is the equation of a circle? Yeah, okay. All right. I can hear that employee is saying her network is not doing well. So, yeah, it is something that you need to consider. It's something that you need to consider. Right. So obviously you're going to get the recording as well at the end. If your network is actually not sufficient, it's, the network sometimes is bad. Okay, we want to find the equation of a circle, and this is the formula, right? So now, okay, the x value is 1, so you can just substitute the 1 in the place of a. Just substitute the 1 in the place of a. So in the place of a, you put 1, and then you square this. In the place of b, you put -1. You square this, which equals r squared, which means you have x minus 1 squared plus y plus 1 which equals, now we want the distance from here to there. What is the distance from here to there? Is the y value. We go up, down, -1 units here. Y is -1. So that the radius is just the absolute value of this. You make it positive, so 1 unit. So, which means that this one is 1 squared. Which means you have this one, y plus 1.
Why?
Yes, please. Any question? All right. Okay. If your network is bad, please, you will have a chance to watch the video because I know the network fails us sometimes. So this is the answer to the question. So yeah, even this, you don't need all this. You can just cut this out. Okay. So we have this. So that is the equation of the circle they want. That is centered at A, but it passes through, it has the x-axis and the y-axis as what? As tangents to it. So yeah. Good question. Next question. Next one. Right, we're looking at the 4.6. If another circle with center N, that is the coordinates P and 3, and a radius of 4, intersects the circle at M at 2 distinct points, determine all the possible values of P. 4.6. This lesson is recorded, so you will watch everything and make sense of everything we discussed here. 4.6. If another circle with center N and coordinates P and 3 and a radius of 4 intersects the circle centered at M at two distinct points, determine all possible values of P. What is the answer? What is the answer? Right, in 4.6, a couple of things we need to consider. The circle that the examiner is talking about here is nothing other than we have the point N and we have the point M. The point N has the coordinates P and 3. The point M has the coordinates what? -2, 3. Okay, it has been given this way. So which means, therefore, we can find this. Um, or R2 minus R1. What is MN? Okay, so we're going to say R2 minus R1 is less than MN, the distance between N and M. It is less than R2, R1. Okay, so this here is the thing we use. Right. What is R2 minus R1? Right, what is R2 minus R1? Right, so obviously we agree that we have basically these two circles that are being considered, but also if you have the distance between them, and would be the same as what? So if you find the distance here, it will be the same as P plus 2. It will be P plus 2. So we continue. And then right now, we find this. So we know that R2 is 5. But the other one has radius of 4. So you subtract 4. The other one has radius 5. The other one has radius 4. Okay? So we have this one here. Or R2 minus R1 is less than Mn, R2 plus R1. So this one is going to be 5. So you also have -2 minus P. Right. Okay, we'll continue. So we also have -2 minus P. As sort of the distance is there. 5 plus 4. 1 P plus 2, 9. So you subtract 2 now. So, right, subtract 2. 1 minus 2 is minus 1. Subtract 2, you get 7. Or here you have this one, which is 5 minus 4 is 1. Minus 2 minus p is less than 5 plus 4 is 9. You add 2 because this 2 is negative. So you add 2. 2 plus 1 is 3 minus p. You add 2 and it gives 11. You divide by negative, so it means you have minus 3 p minus 11. If you divide by negative, the inequality changes what? Changes direction. If you divide by negative, the inequality will change direction, and you get that. So we continue. We continue. So, so we have this. So then you have minus 1 less than p less than 7 minus, so you can write like that. Or the other one can written as minus 11 less than p less than minus 3. So this will be actually the two answers. Watch the examiner's question. So in other words, at this point, if we want to find the two, we just simply consider these two cases. So in other words, you can consider this case or the other case where m has the coordinates minus 2, 3. And the other one has the coordinates p3. Okay, the fact that p3 means the y's are the same. So if p is on the right, then you have a p plus 2 to get the distance, mn. But if p is on the other side, then you have minus 2 minus p, right? So we have that. Right, so just note that question there. This question was given 5 marks. So yeah, we're good. We're so good. We're so good. Okay, we continue. Next question. The next question is this one. You have been given these, and here, you have been given this diagram like this, and they're saying calculate the value of tan theta. Calculate the value of tan theta. 2 minutes. I'm giving you 2 minutes. Please try it. Okay, 2 minutes. Okay. Please let me know when you're done.
Sir,
Yes, please.
is it not PS over OS?
Okay, is it not PS over OS? Well, we shall do the corrections. Right. Okay. So we have this. Right. So with this, okay, I lost Waruna. Okay, if I lose you, just join back. I'm so sorry, the network is bad. Okay. I'm sure the network sometimes it goes bad, but yeah, we are recording this lesson. So if you miss something, it's gonna be uploaded in the next couple of minutes and you can watch the discussion again and make sense of everything. So now, what do we have? Okay. Um, okay. One of you asked me if it is not something over something, in which case, we shall discuss the actual way of doing this question because it is very, very straightforward. So yes, I think that you were on point when you pointed that so this 10 theta is actually the same as in view of SOHCAHTOA. In view of SOHCAHTOA, so we have this one, which is the opposite over the adjacent. Opposite theta is this one, which is y. The adjacent is 12. So y adjacent is 12. Okay. So it would be PS over OS, right?
Yes.
Yes. So yeah, correct. Well done. Next question. Okay, I'm giving you another 2 minutes to find this one, sine theta. What is sine theta? Okay. Okay, please let me know when you're done with it.
Five over 13.
5 over 13. Let's check. 5 over 13. But obviously, you can see that the sine of theta will require the opposite over the hypotenuse. So the opposite is already there. We just need the hypotenuse. So to get the hypotenuse, we have x squared plus y squared, which is r squared. And therefore, this means our x is 12 squared, our y is 5 squared, which equals r squared. So which means r is the square root of 144 plus 25, which is 169. And therefore, this is 13. So which means r is 13. And then now we just need to find the sine, so which means the sine of theta, according to SOHCAHTOA, is the opposite over the hypotenuse. So opposite theta is actually 5. So the hypotenuse is 13. So yes, well done and congratulations for giving the correct answer. It is actually 5 out of 13. This is 5 out of 13. Right, it is 5 out of 13. Next question. Let's look at the next one. All right, in 5.1.3, they are saying determine what? In other words, they're saying determine the value of A if TO. If TO is what? This is T. And T has the coordinates A and B. This is T with the coordinates A and B. So now if T is this one, they're saying determine A, which is this one, if TO is 19,5 units. Okay, the marks are 4. I'm giving you like 2 minutes. Okay. Okay, let's see. All right. Okay, Paul is saying she can't see the question because the network is apparently slow. Are you able to see the question, Waruna?
Yes, sir.
Okay. Waruna can see the question. Okay, obviously I'm giving you a chance. I'm not rushing you because the network sometimes fails. But I understand Paul does not see the screen, the question quite. I'm sure it's going to be like for a few seconds that you're not seeing the question. And then you shall be able to see it. Let me see. Because we're interested in this one, we're doing this one here. 5.1.3. We're doing 5.1.3. Okay, let me know when you're done, please. Anyone who is done? Next one. I'm just saying, please. I need to know if anyone is done. Okay. Okay. All right. You'll forgive me if you can't see the question. I'm sure if you give it some time, because Waruna can see the question. Can you see the question, Waruna?
Yes, sir.
All right. I want to know the value of A, because in 5.1.3, that is what? That is what? That's what we need to do now. Okay. I just have. All right. Paul has given the answer. That's fine, Paul. Thank you for the answer. Then we're going to do it together and see what. Okay. Obviously, Paul thinks that the answer is. So there's an answer by Paul. Paul suggests that A is 20,4. Okay, that is what I'm seeing here. But now let's see what we can get together. What we can get together. It's okay. We are learning here. So we proceed as follows to find the value of A. So we are finding A. To find A, we need to realize that we need to draw a construction like this. And then this angle here is theta plus this one is 90. So is 90 degrees plus theta. So you have the sine or the cosine, depending on the case. But here, this one is x. So x is a and y is b. So it means, therefore, you have, we want to find a, so we can use the cosine function. So we see that the cosine of the adjacent side, which is a, in view of SOHCAHTOA, right? So in view of SOHCAHTOA, what does SOHCAHTOA tell us here? SOHCAHTOA tells us that cosine is adjacent over hypotenuse. So which means with adjacent, the hypotenuse is actually TO, right? So I meant here. Right, so what I meant here was that you have the angle theta, which is exactly 90 degrees plus theta. The adjacent is A over the hypotenuse is TO. Okay, we want A, the TO is what? TO is 19.5 or 19.5 units. In which case, the cosine of 90 degrees plus is the same as what? 90 degrees plus is in the second quadrant, and the cosine is what? It's negative, but it changes to its co-function in view of the Coco rule. So you have the this one, it becomes minus sine theta. What is the sine here? Is minus 5 over 3, which is minus 5 over 3 is equal to A over 19.5. So which means it is minus 5 over 3 is equal to A over 19.5. So you have this one here, and then this is 19.5. You multiply everything. If you multiply everything, you get minus 7.5. So obviously we understand therefore that at this point A is minus 7.5. Okay, it is negative, and we gave that answer. I'm sure that Paul obviously had to rectify a small thing, very close to the actual magnitude of the 19.5 there. But yeah, a fairly good attempt. A fairly good attempt. Next question. Next question. Next question. Okay, obviously I know that you don't need to copy this. You can write your notes after the lesson. Okay, the next question is 5.2. 5.2 says determine the value of the following without a calculator. I'm giving you, I want the final answer to this. I want the final answer to that. Please give me the final answer. Then we shall do it. I'm giving you like 3 minutes, half the time.
Yeah, 3 minutes for now.
5.2.
Okay.
Please try it. Can you see it on the screen?
Yes, sir.
Okay, thank you. Please
No.
try it. I need the final answer and then we shall do it together. I just want to know the final answer, not a lot of the steps, like, you know. Okay, let me know when you're done. Okay, you let me know when you're done. Anyone finished yet? Okay, I lost Mpo. Now I have Mpo back. Finished, guys. We're looking at 5.2, remember? I've just given you like a few minutes to try the question. Okay, are you done, guys? Anyone? Not yet. I need the answer. I don't need like a lot of the steps. You know, we're gonna do it together. But what is the answer? Okay, let's just do it quickly because I know that you possibly are trying there. Right, so this is actually equal to, in which quadrant is 360 minus 2x? 360 minus is actually in which quadrant? It's in the fourth quadrant. In the fourth quadrant, the sign is negative. So this is minus the trigonometric sign of twice x, okay? Right, so we have this. It is therefore multiplied by this one. The sign of this is minus the sign of x. You divide everything. 90 plus is in the second quadrant and the sign is positive. The unit quadrant is 180 plus. It's in the third quadrant. In the third quadrant, the cosine is negative, but you squaring. But you are squaring like this. So what do we get out of these? Right, so what we're getting out of these is that we therefore have the following. So this is minus 2 sine x cosine x into minus the sine of x. You divide everything by the trigonometric cosine of x. Okay, if you square the negative, it becomes a positive. So you have this one cosine squared of x equals cosine divides, and therefore you have negative times negative, which is positive. So it gives you 2 sine squared x plus 2 cosine squared x. So there is a common factor, which is the number 2. So you have x squared plus sine squared plus cosine squared. And this is the number 2. The answer is the integer 2. So we are done, and that is the answer. Any question? Any question? Right, so think about that one. 5.3, it's 3 marks. I'm giving you 3 minutes. 5.3 is 3 marks. They are saying in 5.3, given the square root of that cosine 42 is the square root of k, without using calculator, determine the value of sine squared of 69 degrees in terms of k. If they've given you cosine of 42 degrees equals the square root of k, without using calculator, determine the value of sine squared 69 in terms of k, 69 degrees. Anyone, what's the answer to 5.3? Then we're going to do it together. 3 minutes only. Okay. Three minutes only. We must practice like this and do more examples this coming week. This very week, we are beginning today because Sunday is the first day of the week. So we must practice more. We must solve more problems, you know. We need to do that because time is gone, guys. The exam is like tomorrow. It's like tomorrow. We can't afford to blunder. We can't. So we must double our efforts. We must go all out. Anyone done with 5.3? Let me know if you're done. I lost somebody. I lost Waruna. I lost Waruna. Can you see the question, Paul?
No,
You cannot see the question.
no.
Okay. This is strange. Because I'm speaking about 5.3 and you are not able to see 5.3, right? You can't see it.
No.
No. All right. That's fine. I think it's just a network issue. That's okay. So what I will do is I'm going to post a video of the discussion and you shall see the question 5.3 and you shall try it. So you can try 5.3. I've sent you the paper. It's just Gauteng paper 5.4. You can try the question as well. And 5.5, you can try the question as well. You have the graph question here. like this. All right. So what I'm going to do is, yeah, let me just conclude this discussion because we have gone just above beyond time. And I think that even I lost Waruna. I don't know why she's off totally, but that's fine. Let me do this. Let me just end this discussion. Then I'm going to post the video. Okay.
Okay.
Yeah. And then we need to talk about when we can meet again. You let me know during the week, the time, 8 p.m., 7 p.m., the starting time during the week. We need to do something at least twice or 3 times every week. It's just so bad. Time is limited. Okay, thanks, Mpo, and goodbye. Okay.